Now let's solve this problem in Java. In the previous video, we have computed this using the bottom-up approach by using these two algorithms. Now we are going to do the same thing in Java. So in IntelliJ, I'm in the presentation mode. So let's start solving this problem. I'll create this method first. Call this at Knapsack. I will take capacity as an input, capacity of the knapsack bag. This is the weights, panel and values, right? Yep. Value for each item, and also total items. I'll just value and items. These are the four parameters or arguments passed to this. And now we had to create this 2D array, right? And then we had to compute for each of them one by one, starting from here to here, using the formula that we deduced in our previous video. So 2D array, I'll call this as DP again. And the rows are here. Total items are 5. So 5 plus 1 for empty case, the base case. So it should be total items plus 1. And similarly for capacity, in this example it was 15 kg, 15 plus 1 for the base case. So it would be capacity plus 1. All right. And because by default we don't need to fill these base cases here for this column and this column, because by default arrays are in Java are defaulted as 0 when they're initialized. We'll start with 1. Mark it as 1, and it should go less than equal to total items, right? But I is the row, so we start from here to here. This is I, and for the columns or the capacity, I will again use the capacity. It's less than equal to capacity, starting with 1. We don't need to start from 0. Okay, and then let's check for the conditions that we discussed, right? So say, for example, if weights of the current item I minus 1, because starting from 0, index starts from 0, so it's less than the capacity. Because if it's more than the capacity, I mean, this is the scenarios where, for example, here the capacity is 1 and the weight of the item is 12, then it would be always 0. So we don't need to consider those cases. We keep it as 0. This only matters when the weight of this item is less than or equal to 12, the capacity 12. So this is the condition that we have put here. If capacity is if the weight of the current item is less than or equal to the capacity, only then we have to calculate the formula. Right. So this is this scenario. Other scenarios we have just ignored it. So we again use this formula that whether to not choose this item. In that case, we will just copy whatever is there from the up cell to the down one. Or if we choose this item, then we have to do the max of this value of 4 plus whatever was there by 12 minus the weight of 12 is 0. So this one. So of course it will be 4 here. So the same formula as we came up in our previous video, we are going to apply the same. So here, this is the condition. So we will see that if dp of I ij, I mean the current one item would be current. I mean we're talking about this cell here. So it's max of, right? Max of these two items. So it would be either the cell above it if you don't choose this. So it should be dp I minus 1. This is the cell above it, right? I minus 1 is like the row above, and the column is same j, so it should be just one cell above it, this one. Or if we include this item, so it would be value of this current item plus, we need to, so value of this current item is 4, as we create the formula here, 4 plus value which was there by 12 minus weight of this 12, 0. So it would be dp of I minus 1, which is the above row, and j minus the weights, I mean the current weight that we have used. So j is 12 here. So we're talking about this cell. So j is like 12 minus the weight of current item is 12. So this the weight of current item. This is how we got to this cell. From here, we got to this cell. So this is this value. Okay, that's it. Whether we choose this or not, again we don't choose this item. This is the cell, and this is when we include this item, and this is the formula as we just discussed. Otherwise, it would be just taking from above it. This is a scenario when the weights are greater than the capacity, so it would be reported as 0 or whatever the value was there before it, because you're not including this item. Again, this one is there when the weights are greater than the above capacity, so it means that we are not including that item. This is the same scenario as we discussed here when we don't include the current item. So we just take the value which was computed before, excluding this item. This condition matches here. And finally, if we go to the for loop here, we need to return the last cell here. So guys, that's it. Although I mean we have like solve this problem in trying to understand it, but the formula was just reduced to these two, and you see that this code is just few lines, and we got the solution. That's the beauty of dynamic programming problem. Now let's test run this with the example given here in Hacker Earth. So two integers n and c. This is the number of items. This is the capacity. This is the value, and these are the weights of each item. So let's try to scan this and run this problem. So we are using a scanner here. I will take input from keyboard. Mark this final. So first input line, as we see in this example, the first input line is this, which will give me n, that is number of items, and 20 as the capacity. So final int total items this the first one. So I will take first input line 0. Okay. Similarly, I will take the capacity as the second, 4 and 20 capacity, and these are now the third. The second line would be the values, and the third line would be weights. So let's calculate this. You will just copy this. Second input line. I will store it into values first. Second line is for values, and it would be total items, right? I insert 0 total items values of I is equal to this. Should be I. Okay. Now for the third line, which is for weights, it should be similar pattern here. Just need to change a bit on the variable names. Third input line, and then weights, and attached to this weights of I should be third input line, right? Okay, we have scanned all the inputs here. Now we just call this method knapsack with capacity, weights, values, total items. Let's run this. Okay, let me spend the output. Let's copy this. Expected output is 13. So let's see whether our algorithm is correct. Okay, so it gives me 13. Now let me just copy this into Hacker Earth and see for all the different cases it has, it passes all of them. So I will copy this first. Okay, here we go. So in the same as main here, I have copied here, and now I need to copy my knapsack method. Right, and compile and test code. Okay, let's submit it. Okay, it's accepted. Yeah, so it's working well. So that's it about this knapsack problem. Let's finally quickly do the time and space complexity. So we can see that the time complexity would be, you are having two for loops here with total items and capacity. So it would be O of total items multiplied by capacity, or in general terms it's O of n square. And similarly, it goes for DP array as well, because we're creating a 2D array. The space complexity and time complexity both would be O of n square. So that's it about this knapsack problem, guys. In the next video, which is our 8th problem, we'll solve the word break problem, which is in the lead code. So see you in the next video.